Hello DevOps friends, welcome to my channels. I'm Jochen the Monospace Mentor, and today is a very special day. We're launching Basic Linux System Administration, my free live stream system administration course, and I'm happy to have you here. Hello everyone. Hello QuickDraw. Hey Failed Sleep, how you doing? And today we're going to start looking into Linux system administration. We'll start with a little bit of history and a few basics. And in the coming weeks, we will then go into all kinds of topics. So maybe let's just take a look at what these topics are going to be. We will talk about fundamentals, the history of Linux, about file management, how to manage users and groups. We will do process and service management, package management, software installation, networking fundamentals, system monitoring and performance. We'll look into basic shell scripting and automation. We'll talk a little bit about security, and we definitely need to talk about backup and recovery as well. And today we'll start with the fundamentals. I'm going to start at about 15 past, so people can still come in, and until then we can get warmed up and talk a little bit about how this is going to work here in terms of interaction. Let me catch up with chat. QuickDraw says, good here, actually looking to get some higher education, which could perhaps help out in my line of work, but I'm not entirely sure. Well, education always helps, and that's part of the reason why I'm doing this. I've been in software development since 1984 and started Linux system administration in 1993. Learned a lot from other people, and I want to simply pay it forward. And maybe I can help some of you get into system administration as well, or improve your chances of leveling up in your career. And if that happens, then I'd be the most happy person. And today I'm going to start doing this course. It's the first time I'm doing this version of the course, and it's the first time I'm doing it on 3 streaming channels at the same time. So bear with me while I'm finding my feet myself. I hope this is going well. I hope my broadband is going to hold up, and we'll see how I can deal with lots of windows and things that I have here simply to make this course a very interactive and very educational event. I'm not going to be able to look at chat all the time because I'm busy with my materials here. So what we are going to do is we'll use a course interaction platform called Vvox, but you can simply go to my website. If you use the command !interact, it'll get you to the right page, and on there I have a few guidelines how we are going to work together here, and I also have the interaction platform built in under the heading course participation. There is the homepage, but the most interesting thing is the Q&A page with the speech bubble icon. Here you can leave your questions. Whenever you have a question about stuff that we are talking about, then please type it in. But first, simply check and see if someone else has already written an equivalent question. If that's the case, you can simply upvote them, give them a thumbs up, and I can see that multiple people have the same question. and I'll do my best to answer all the questions as far as our time allows. I'm aiming at a duration of about 2 hours. I'm not sure where we are going to land because these topics and modules are of different length, but that's the rough spot where I'd like to be. And yeah, we'll see how this is going to work out. That's also a little bit of an unknown for me, because yeah, this is the first time I'm actually doing these materials, and so we'll see how much time we'll need and how quickly I have to go through them to stay within my time frame. Regardless, if you're using the Q&A board or if you are using chat, please be helpful. Try and not derail your peers here. We all are here to learn something, including me. I'm certainly going to learn a lot today and in coming sessions. So please make sure that you add value for all of us. Don't go into huge memeing sessions or pull out other topics and things like that. At the end of this session, I'm also going to enable a survey. This will create a third icon with a clipboard, and there you can leave me some feedback, so I get to know a little bit about how well I met your expectations, and if there are things that I can improve. There's already a test question on the Q&A board. Thanks for testing that out. So we already know that the board is actually working. All right. So again, the interact command with an exclamation mark in front gives you the link. Some of you have already used it, and there you should have everything to participate in the course. You can still, of course, hang out in chat as well and talk there as well. But as I said, I'll not be able to catch up with chat all the time, and that's why I have the Q&A board. Any questions from your side so far? Before we've really started, you can of course ask questions in chat as well. What we could do to get to know each other better is to, if you could write 1 or 2 simple sentences, why you are here, what you'd like to learn, what interests you the most. I'm sure there are many different perspectives here, and I would love to learn more about what brings you here and why you are interested in this course. As I said, I'm here because I love sharing my experience. I learned from thousands of people in the open source community, and I hope I can contribute a little bit this way in my own way and help others to grow and build a career out of open source, just like I did. I did all kinds of stuff with Linux. I did system integration. I worked as a SUSE certified Linux trainer. A training gig actually got me a management position at a major internet provider. And when I left that job, I decided to do my own business again. So for the last 15 years, I've been running a managed hosting company where we run hundreds of Linux servers at scale for customers who pay for us to keep their websites online. And so Linux and open source in general has become the center of my complete professional career and my business and my existence. It does pay my bills, and I hope that other people get into a position to do the same. Quickdraw, if you'd like to ask something like that, I recommend simply joining our Discord. The ! Discord command gets you an invitation if you're not a member already, and feel free to ask there if there's anything that you find off topic at the moment. So, who has joined us? We have Mystifying Disc, Florian, hello. Voiljan, hello. And Praxeus, community member of the server room, good to have you here. Competent Iria, hello. And Olivier, hey, how you doing? S6M4C, how you doing? Welcome everyone. I guess we're getting ready to get started. Again, the interact command guides you to the page where you can interact during the course, where you can take part in polls, in assessments, where you can check your own knowledge, and especially where you can leave your questions for me. The way that I'm going to do this is we are talking about Module 1 Linux Fundamentals today, and this topic, this module is divided into 6 chapters. And after each chapter, or let's start otherwise, I first do a bit of a lecture about the topic. I'll tell you about the important facts of that topic. We'll do a little bit of practical exploration, of course. Practice is absolutely important in system administration. You can't just pick up a book or do a video course or something like that and then consider yourself a system administrator. You have to have practice, and so this course will include practice as well. I would like to invite you to try and do a few of the practical experiments yourself. We'll start by installing Linux in a virtual machine, and I'll use my virtual machine then to demonstrate things as we're going along as well. And after each lecture part, I'll do a Q&A session, so we'll collect the questions that have come up on the Q&A board, and I'll try and answer as many as I can, and then we'll do an assessment quiz where you can show what you've learned. And then when we've finished that quiz, we then go to the next chapter, and hopefully we'll get to the end of chapter 6 then later today. So let's get ready to start. So, set up here. This is looking good. So, let's get going. Welcome to Basic Linux System Administration, our live stream course. There are other modes in which I do this course as well. I also do cohort-based courses that I can make a little bit more interactive, where I can go a little bit deeper into specifics for participants. And when the cohort for September didn't get together, I decided to do a live-streamed course instead. And here we are. Welcome, everyone. And the first chapter in Module 1, Linux Fundamentals, is called Introduction to Linux and Open Source. This first foundational section will give you the essential knowledge you need to understand Linux's place in modern technology and why it has become the backbone of internet infrastructure, cloud computing, and enterprise systems worldwide. By the end of this section, you will be able to explain the history and evolution of Linux from its origins to enterprise adoption, articulate the key principles of open source philosophy and community-driven development, compare and contrast Linux with Windows and macOS in enterprise environments, identify the major Linux distribution families and their use cases, and finally describe Linux's critical role in modern infrastructure and cloud computing. Let's go back in history to the birth of Linux. In 1991, a 20-year-old Finnish computer science student named Linus Torvalds was frustrated with the limitations of existing operating systems available for his Intel 386 PC. There was Windows, of course, there was DOS, there was Minix, which is a Unix-like operating system, but it's mainly used for teaching and not really for day-to-day use. And Linus wanted something similar to the powerful Unix systems he used at university. But Unix was expensive and not designed for personal computers either. So he decided to create his own operating system kernel as a hobby project. Torvalds announced his project on a Usenet newsgroup with a now famous message. Hello everybody out there using Minix. I'm doing a free operating system, just a hobby. Won't be big and professional like GNU for 386, 486, 80 clones. This has been brewing since April and is starting to get ready. So note that this message was in August, so it only took Linus 4 months to build this basic operating system kernel. The quote goes on, I'd like to any feedback on things people like, dislike in Minix, as my OS resembles it somewhat, same physical layout of the file system due to practical reasons, among other things. I assume the practical reasons are that he needed to use Minix for lectures and still wanted to use his operating system as well and use the same file system or access the same file system from both operating systems. He goes on, I've currently ported Bash and GCC and things seem to work. This implies that I'll get something practical within a few months, and I'd like to know what features most people would want. Any suggestions are welcome, but I won't promise I'll implement them. Little did you know that this hobby would revolutionize computing. The key innovation wasn't just technical, it was social. Torvalds released his kernel under the GNU General Public License, making the source code freely available for anyone to study, modify, and distribute. This decision attracted developers from around the world who began contributing improvements, bug fixes, and new features. The collaborative development model that emerged became a template for successful open source projects. By the mid-1990s, Linux had evolved from a student experiment into a robust operating system. Companies began taking notice as Linux demonstrated stability, security, and performance that often exceeded commercial alternatives. The late 1990s saw the first major enterprise adoptions, with companies like IBM making billion-dollar investments in Linux development and support. Billion-dollar investments in the 1990s, to be sure. Today, Linux powers everything from smartphones to smart TVs to the world's most powerful supercomputers. It runs the majority of web servers, cloud infrastructure, and embedded systems. Understanding Linux's journey from hobby project to enterprise standard helps you appreciate why it's become such a critical technology in modern IT careers. The story of Linux demonstrates how open collaboration can create technology that rivals or surpasses what large corporations can build in isolation. This collaborative approach has shaped not just Linux itself, but the entire landscape of modern software development, from version control systems to cloud-native applications. Let's go back to free and open source. Open source represents a fundamentally different approach to software development than the traditional proprietary model. At its core, open source means that the source code is freely available for anyone to examine, modify, and share. One of the most important activities of the organization called Open Source Initiative, OSI, is as a standards body maintaining the open source definition. But this technical definition only scratches the surface of what makes open source powerful. The philosophy behind open source rests on several key principles. First is transparency. When source code is open, anyone can inspect it for security vulnerabilities, bugs, or inefficient implementations. This many eyes make all bugs shallow approach often leads to more secure and reliable software than closed source alternatives, where only a small team of developers can review the code. Being able to read other people's source code is an invaluable opportunity to grow as a programmer and software engineer. Nowadays, many people just browse code repositories to spot interesting code and algorithms. Being able and legally allowed to take existing code and modify to your own needs is another unique feature of open source software. In recent years, this also enabled the open source community to fork the repositories of widely used softwares like Redis and Terraform when their owning businesses decided to discontinue publishing updates under an open source license. Then there's the principle of collaboration over competition. Instead of multiple companies duplicating effort by building similar and competing solutions in isolation, open source allows developers to work together on shared foundations. This collaborative approach has produced some of the most successful and widely used software in history, including the Linux kernel, of course, but also the Apache web server and the MySQL database system. The open source model also enables what is often described as standing on the shoulders of giants. Rather than building everything from scratch, developers can build upon existing open source projects, focusing their innovation on the unique value they want to add. This has accelerated software development across industries and enabled the rapid pace of innovation we see in modern technology. And then, of course, there's also the commercial side of things. From a business perspective, open source provides several advantages. Companies can avoid vendor lock-in, reduce software licensing costs, and customize solutions to meet their specific needs. Many successful businesses have been built around open source software, either by providing professional support and services or by building proprietary features on top of open source foundations. Sorry for the ad break on Twitch. I add, without saying more, without violating the terms of service. So yeah, we were talking about the business advantages. I think they are pretty obvious. Adjacent to, sometimes even opposite of business is of course community. Open source isn't just about individual projects, it's about communities. Successful open source projects develop ecosystems of users, contributors, and businesses that sustain long-term development and support. Understanding these community dynamics is crucial for anyone working with open source technologies professionally. The open source model has proven so successful that even traditionally proprietary companies like Microsoft, Oracle, IBM have embraced it as a core part of their technology strategy. This shift reflects a broader recognition that collaboration and transparency often produce better outcomes than isolated development efforts. There is, however, also a downside of open source. We should not discount the downsides that many open source developers deliver tremendous work unpaid in their spare time. Burnout is all too common, with developers struggling to keep up with the maintenance of both their software and their user communities. And increasingly, big businesses are happy to benefit from open source software free of charge, but at the same time, put up demands that maintainers and developers are not able to meet. For example, there are actually big enterprises that are more than happy to use open source projects and then go ahead and ask the maintainers of said software to fill out huge software bill of materials sheets for their compliance needs, expecting these developers to do that in their spare time as well, without even offering any kind of compensation. And I think that this has to change. There is still a lot of work ahead for us to create an environment that allows for sustainable open source software development overall. In the enterprise context, Linux is, of course, absolutely dominant. When you're starting your career in IT, you'll quickly discover that the choice of operating system isn't just about personal preference, it's a strategic business decision with significant implications for cost, security, performance, and long-term flexibility. Understanding how Linux compares to Windows and macOS in enterprise environments is crucial for any aspiring system administrator or DevOps engineer. Linux dominates the server market with over 80% market share, and this dominance isn't accidental. Linux servers can run for months or even years without rebooting. We do have these kinds of servers ourselves with uptimes of 1,500 days, making them ideal for critical applications that need high availability. The stability comes from Linux's Unix heritage, which was designed from the ground up for multi-user, multitasking server environments. From a cost perspective, Linux offers significant advantages in enterprise deployments. While Windows Server requires per core or per user licensing fees that can quickly add up in large deployments, most Linux distributions are freely available. This doesn't mean Linux is free in enterprise environments. Organizations typically pay for support, training, and additional tooling, but the base licensing costs are dramatically lower. Security is another area where Linux shines in enterprise environments. The open source nature means security vulnerabilities are quickly identified and patched by the global community. Linux's permission model and architecture make it inherently more resistant to malware than Windows. And additionally, the ability to remove unnecessary components and services reduces the attack surface significantly. Windows maintains strong positions in specific enterprise niches, particularly in environments heavily integrated with Microsoft technologies like Active Directory, Exchange, and SharePoint. Many organizations run hybrid environments where Windows handles desktop computing and office productivity, while Linux powers backend services and infrastructure. Apple's macOS, while popular among developers and creative professionals, hand up who's using a MacBook, I don't anymore, has limited enterprise server presence. However, it's worth noting that macOS is built on Unix foundations, similar to Linux, namely on the BSD branch of Unix, which is why many developers find the transition between macOS and Linux relatively smooth. The rise of cloud computing has further cemented Linux's enterprise position. All major cloud providers, Amazon Web Services, Microsoft Azure, Google Cloud Platform, run primarily on Linux infrastructure. Even Microsoft's Azure Cloud runs more Linux instances than Windows instances, which highlights how the industry has embraced Linux for cloud-native architectures. For your career development, this means that Linux skills are increasingly essential, regardless of your organization's desktop environment. Even if you work primarily with Windows systems, understanding Linux is virtually mandatory for cloud computing, containers, DevOps practices, and modern application development. So let's take a closer look at what Linux actually is when you try to get your hands on it. One of the most confusing aspects of Linux for newcomers is the bewildering array of distributions available. Unlike Windows or macOS, where you have essentially one version per company, Linux comes in hundreds of different flavors called distributions or distros. Understanding the major distribution families and their characteristics is essential for making informed decisions in professional environments. The Red Hat family represents the enterprise-focused branch of Linux development. Red Hat Enterprise Linux, short RHEL or RHEL, is the commercial flagship designed for mission-critical business applications with long-term support, guarantees, professional support services, and rigorous testing. Fedora serves as the community-driven testing ground for technologies that eventually make their way into RHEL, making it an excellent choice for developers who want to work with cutting-edge features. I myself am a big fan of Fedora, and this is also the reason why we are going to use Fedora in this course. CentOS Stream provides a free community-supported distribution that closely tracks RHEL development, offering a middle ground between bleeding-edge Fedora and the conservative RHEL. Then there's the Debian family, which emphasizes stability, security, and adherence to open source principles. Debian itself is known for its rigorous testing process and commitment to software freedom, making it extremely stable but sometimes conservative about adopting new technologies. Ubuntu, which is based on Debian, has become one of the most popular Linux distributions by balancing Debian stability with more frequent updates and better hardware support. Ubuntu's corporate backing by Canonical provides professional support options that make it attractive for enterprise use. The SUSE family, with its German engineering roots, focuses on enterprise reliability and integration with existing IT infrastructure. SUSE Linux Enterprise Server, or SLES, competes directly with RHEL in the enterprise market, while OpenSUSE provides the community-supported version. SUSE is particularly strong in European markets and has excellent integration with SAP applications, so more enterprise-oriented. And then there's Arch Linux, a rolling release Linux distribution, which means that it constantly delivers updates to its software packages. While this distribution has a focus on minimalism, its Arch User Repository, AUR, complements the official package repository with a vast selection of software. Arch Linux has comprehensive documentation in the form of a community-run wiki known as the Arch Wiki. Thanks for the comment, Praxeus. Yes, please go to the link if you have any questions. The command !interact will give you the URL as well. These are the major Linux distribution families. Each of them has developed its own package management system, which affects how software is installed, updated, and managed. The Red Hat family distributions use RPM packages managed by Yum or DNF. Debian family uses Deb packages with apt as its package manager, and SUSE uses RPM as well with Zypper. And Arch uses its own binary PKG packages with Pacman as the package manager. Remember these for the assessment later. These differences matter in professional environments because they affect automation scripts, deployment procedures, and administrative workflows. The choice between distributions often comes down to organizational requirements rather than technical superiority. Enterprises typically choose based on support availability, compliance requirements, integration with existing systems, and staff expertise. Many organizations standardize on one distribution family to simplify training, automation, and support procedures. Understanding these distribution families helps you make informed career decisions too. If you're planning to work in enterprise environments, gaining expertise in RHEL or Ubuntu Server will serve you well. If you're interested in cloud-native technologies, Ubuntu and Fedora are popular choices. For DevOps roles, familiarity with multiple distribution families is often valuable, since you'll encounter different distros in different environments. Speaking of cloud computing, the modern technology landscape has been fundamentally shaped by Linux's dominance in infrastructure and cloud computing. Understanding this dominance isn't just academic, it directly impacts your career opportunities and the skills you'll need to succeed in today's IT environment. Cloud computing has been the primary driver of Linux adoption in the last decade. Amazon Web Services, which pioneered cloud computing, built its entire infrastructure on Linux. Microsoft Azure, despite being from the company that created Windows, now runs more Linux virtual machines than Windows ones. And Google Cloud Platform, built by a company that has used Linux internally for decades, naturally standardized on Linux for its cloud computing services as well. This means that regardless of which cloud platform you work with, you'll be interacting with Linux systems. The rise of containerization has further cemented Linux's position. Docker containers, which have revolutionized application deployment, run natively on Linux. Kubernetes, the container orchestration platform that has become the de facto standard for managing containerized applications, was designed for Linux environments. While Windows containers exist, the vast majority of containerized applications run on Linux, making Linux skills essential for modern application deployment and management. DevOps practices which emphasize automation, continuous integration, and infrastructure as code have flourished in Linux environments. Tools like Ansible, Terraform, Jenkins, and GitLab CI/CD were built with Linux-first architectures. The scriptability and automation capabilities of Linux make it ideal for the kind of automated deployments and infrastructure management that DevOps teams require. Microservices architectures, which break applications into small, independently deployable services, rely heavily on Linux-based infrastructure. The lightweight nature of Linux containers makes them perfect for hosting microservices, and the networking and orchestration capabilities of Linux-based platforms like Kubernetes provide the foundation for managing complex microservices deployments. Edge computing and Internet of Things deployments represent emerging areas where Linux continues to expand its influence. From smart city infrastructure to industrial automation system, Linux's flexibility and resource efficiency make it the preferred choice for edge deployments where traditional desktop operating systems would be impractical. The financial implications of this dominance are significant for both organizations and individuals. Companies that embrace Linux-based infrastructure can achieve dramatic cost savings through reduced licensing fees, more efficient resource utilization, and greater flexibility in vendor selection. For individuals, Linux skills command premium salaries in the job market because they're essential for cloud computing, DevOps, and modern application development roles. This trend shows no signs of slowing down. Emerging technologies like AI and machine learning workloads predominantly run on Linux infrastructure, Even areas like automotive computing and aerospace systems are increasingly adopting Linux-based solutions. Linux is run even on Mars. For your career development, this means that Linux skills aren't just useful, they're becoming fundamental to working in modern technology environments. Whether you're interested in system administration, cloud architecture, DevOps engineering, or software development, Linux knowledge will be essential for advancing your career and staying relevant in the rapidly evolving technology landscape. The concepts that we've covered in this section directly impact your daily work in IT and system administration roles. When you join an organization, you'll likely encounter Linux systems in multiple contexts, from the web servers hosting your company's websites to the cloud infrastructure running your application services. Understanding Linux's history helps you appreciate why certain design decisions were made and why Linux-based solutions are often preferred for critical infrastructure. The open source philosophy isn't just academic, it affects how you will evaluate and select technologies, how you'll contribute to projects, and how you'll build your professional network. Many successful IT careers have been built around contributing to open source projects, and understanding the community dynamics will help you engage effectively with these ecosystems. The distribution landscape knowledge becomes practical when you need to choose platforms for new projects, migrate systems between environments, or troubleshoot issues across different Linux variants. Many IT professionals specialize in particular distribution families, and this specialization often influences career opportunities and salary potential. Before we get to the Q&A, let me just check if there's anything else I'd like to say. Nope, it's fine. So let's go to our first Q&A session. So we have two questions on the board. Again, if you just joined us here, this is the first session of Basic Linux System Administration, and it's my live-streamed, free-to-join Linux administration course that I'm doing on all three of the streaming platforms that I use. If you'd like to take part in this course, simply enter the command !interact, and it'll get you to a web page on my website that tells you everything. Here's our first questions. There are new questions popping up on the board. Nice. First question, where do I find the board? As I said, the !interact command gets you to a link ending with module-01, and by following this link, you go to the participation page. At the bottom of this page, there should be the interaction platform where you can add questions, where we'll also do the assessment in a minute or two, and where we'll do the feedback survey at the end of this session. If this participation board doesn't appear in your browser, maybe check if you have extensions installed that prevent it from getting rendered. Thanks for the feedback, fell asleep. Background music is a little bit too loud. I'll be happy to turn that down a little. But let me then just make sure it stays down as well. I need to change my configuration a little bit. Just a second. Okay, that should do the trick. So if you have any issues getting to the participation platform, please let me know. Is it this? monospacementor.com/courses/lindsys-1/module-01. Yes, that's correct. That's the page. And it should have the interaction platform at the bottom. If that's not the case, then you can also go to vvox.app and enter the ID that you can see at the left here, 142-931-238, and that's the same platform. Then we have a question that got upvoted 3 times. Where does Alpine fit in the district breakdown? Alpine is its own kind of family as well. It definitely has a bit of a niche existence, but it is well used in the container deployment environment, because Alpine is very, very minimal and allows very small payloads that need to be deployed when you do container-based deployment. So Alpine is definitely popular, but in a more narrow space in the industry, I would say. And then there's the question, is Guix count here? Does it count here, or is it just too small niche or part of another family? That's a good question. I know the name, but I've never looked into it. I'll have to leave that question unanswered, at least in part, because yeah, I don't have any personal experience with it. It's definitely a niche thing. And I'm pretty sure it's also going its own way in terms of implementation. As far as I know, it's not based on any of the major families. It's, I think, its own thing. Is it related to Nixos? Because that's another operating system that is becoming more and more popular. But yeah, still also has more of a niche existence. Now, keep these questions coming. I am well aware that this initial chapter on the history of Linux will not cause a lot of questions. So I'd say let's go right ahead into the assessment. So if you are on the participation platform, you can answer these questions. Who created the Linux kernel and in what year? Was it Richard Stallman in 1985? Was it Linus Torvalds in 1991? Was it Andrew Tannenbaum in 1987? Or was it Ken Thompson back in 1969? Let's run a 30-second timer, and then we'll see who's paid attention. Here we go. The Linux kernel was created by Linus Torvalds in 1991. Richard Stallman founded the GNU project, whose goal also was to create a full operating system. And the GNU project succeeded in creating basically everything necessary for an operating system, and was just missing the operating system kernel at the center of everything. And that's where Linux came in and basically provided the final missing puzzle piece. Linus, of course, created Linux, Andrew Tannenbaum created Minix, which we've mentioned earlier. And Ken Thompson, of course, together with Dennis Ritchie, created Unix, the forefather of all these Unix-based, operating systems. Which of the following best describes the open source philosophy? Is it software should be free of cost but not modifiable? Is it source code should be available for inspection, modification, and redistribution? Is it only educational institutions should have access to source code? Or is it software companies should share code only with their customers? That's an easy thing. Waljan says, I think GUIX is NixOS with a Lisp-like language instead of Nixlang. Okay, so it uses a different functional language as its control center, basically. Thanks for that. Answers are mostly on source code should be available for inspection, modification, and redistribution, which is definitely the right answer. Now, what is the primary package management tool used in Fedora Linux? I mentioned it in passing. Did you pay attention? Is it apt? Is it zipper? Is it DNF or is it portage? Some say apt, some say zipper, and many say DNF, and it's actually DNF. It was Yum before DNF, and Fedora just introduced a new version of DNF that is even more powerful as a package manager. Which distribution family does Ubuntu belong to? To Red Hat? To Debian, to SUSE, or to Arch? Hey Balthazar, how you doing? Balthazar is another member of the server room, my DevOps community of practice. If you'd like to join a bunch of very, very competent people, and me, then check out theserverroom.sh. Everyone says it belongs to the Debian family, and everyone is correct. I'll wait for the ad break to finish. Opportunity to hydrate. Okay, so let's go on. What percentage of web servers run on Linux? Is it about 30%? Is it about 50%? Is it about 65%? Or is it about 80%? Yes, it's 80%, around that. Absolutely dominating the market. Which license did Linus Torvalds choose for the Linux kernel? Was it the MIT license, the BSD license, the GNU General Public license, or the Apache license? By the way, it's a good idea to know at least the major differences between these open source licenses. All of these exist. They are not invented by me. Because yeah, the differences between these licenses are often very subtle and determine how you can use and distribute the software behind the license. Most say GPL, and there's also a vote for Apache license, and it was the GPL. What is the primary advantage of Linux in cloud computing environments? Is it better graphics performance? Is it lower licensing costs and better scalability? Is it built-in antivirus protection? Or is it automatic backup capabilities? Most of these are important aspects of running IT infrastructure. But which is most important in terms of cloud computing? Oh, didn't set a timer, but I think we should be mostly done. Let's see, 9 out of 13. Nightwolf says I want to select more than one here. That's why the question says primary advantage. There are more than just one. But one is definitely there. And all of you say lower licensing costs and better scalability, which is of course correct. Which of the following is not a major Linux distribution? Is it the Red Hat family, the Debian family, the Puppy family, or the SUSE family? Yes, it's the Puppy family. It does exist. I did not invent that either. There is Puppy Linux, but it's definitely not a major one. Not throwing shade, Wyjan. Just saying it's not a major one. Now, there are also questions that you can answer in text, if you like. You can do that at home as well. So let's do a 1-minute timer. Just write a few keywords, explain why Linux has become dominant in server and cloud computing environments, mentioning at least 3 specific advantages. Let's put you under a bit of pressure here. Seconds. These are great answers. Stability, reliability, security. It's the perfect gaming OS, I agree. I do game on Linux as well. Command line interface, transparency, multi-user by default, yep. Reliable, low cost, expandable, accessible for everybody. Free and open source software, less malware. Microsoft is trash, I do not disagree either. Yep, good. Good answers. Describe the key differences between the Red Hat and Debian distribution families, including their package management systems and typical use cases. Again, just a few words are absolutely sufficient because, yeah, we can only run this for a minute. This is not an examination. I think we'll have to speed up a little because we've already been going for 45 minutes now. Typical use case is running containers on top of it, so it doesn't matter. And Debian does not offer a corporate support plan. Red Hat lies to upstream and downstream contributors. DNF is legitimately better than apt. Okay. I will go ahead and skip the last question. How has the open source development model contributed to Linux's success, and what are the implications for organizations considering Linux adoption? It is an interesting question, but I want to save a little bit of time here. So we'll jump right to the answer here. Collaborative development leading to rapid bug fixes and feature development, transparency improving security and reliability, community-driven innovation, avoiding vendor lock-in, cost benefits, support models, and training needs. All right. Now, let me set up the next section, which is going to be Linux installation. Give me just a minute, and in the meantime, feel free to chat. If you've joined us in the meantime, this is my live-streamed course, Basic Linux System Administration, which we are going to run for the next coming weeks. At the same time, Thursday at 6 p.m. Dublin time. And the exclamation mark Linux course command gives you a link where you can learn more about this course, and the exclamation mark interact command tells you how you can actually take part here, especially where you can post your questions and take part in these assessment quizzes. Now, let me do some reshuffling here behind the scenes. Mystifying Disk says, I do not understand this exclamation mark thing. It's simply entering the command in chat, exclamation mark interact, for example, and that will cause the bot to answer. Just enter it as a chat message. It's basically like a chat bot. Now, here we go. All right, that's better. Okay. Now let's see. So I can actually do this. And then do this. Yes. All right, so let's go into the next chapter, which is practical Linux installation. Oh, wait. I have to do one more thing here. So, here we go. Installing a Linux distribution is one of the most fundamental skills you need as a system administrator or DevOps engineer. While cloud instances and containerized environments are increasingly common, understanding how to perform a complete operating system installation gives you deep insights into system architecture, storage management, and the boot process that you will rely on throughout your career. So, this session will walk you through performing a complete Fedora installation in a virtual machine environment. And I'd say, let's go right into it. You can use different ways of installing Fedora or Linux in general, but we'll focus on Fedora. I will use a VM-based installation. There are many VM hypervisors out there. There's VirtualBox on on all three major operating system. VirtualBox is available for Windows, for macOS, and for Linux there's VMware as a desktop version. And I'm going to use Virtual Machine Manager on my workstation here to do a Fedora installation. Nightwolf says Docker run Fedora latest is also possible, but that will require you to already have a system where you can run Docker on. And so we'll still have to solve this bootstrap problem. Here's my desktop where I have Virtual Machine Manager running. And I will start by creating a new virtual machine with a local install media in form of an ISO image. You can download this ISO image from the Fedora website. I already did that, so I can actually select it here Fedora Workstation 42, which is the current version of Fedora. I'll choose that, and the hypervisor will then simply provide this ISO image as a virtual CD-ROM as to install. Yes, I know it's very small. There is actually is there a way to make this easier to see? I guess I will solve that for the future if yeah, I need to pay more attention to this. Bear with me while we do this. I'll simply choose the resources here. Let's talk about them. The three major resources we need to provide to our VM from the host system are memory, CPU as a compute capacity, and storage as a virtual disk. And I'll stick with the defaults that get suggested to me here, which is 4096 megabytes of memory, 4 gigabytes of memory, 2 CPUs, that should be sufficient for our purposes. And in the next step, it asks me to create a disk where I choose 20 gigabytes of capacity. That should also be enough for our demo purposes. And this is already everything that is absolutely necessary. So I get this summary here. We'll install Fedora. It did recognize that from the ISO image.
System. I know this.
And it'll use 4 gigabytes of RAM, get 2 CPU cores, and 20 gigabytes of disk storage. Let's click Finish. And it'll start a virtual machine and offer me write the boot manager of the virtual CD-ROM. And I'll go into Start Fedora Workstation Live. Live means this is basically a Fedora distribution that runs right off the virtual CD-ROM drive. So I could start using this Linux distribution right when it's finished booting. The only thing is I can't store any data on the virtual CD-ROM, of course, so I would have to maybe provide a USB stick or something like that that I can attach to this VM if I wanted to run Fedora here right from the CD-ROM or DVD and still be able to store files. But we are only booting this to install Fedora on our VM. And so I'll click the button Install Fedora. That pops up automatically. Mystifying Disk asks, where do you execute the virtual machine manager? So you need a hypervisor, a manager for VMs on your operating system. And there are hypervisors for all major operating systems. As I said, for example, VirtualBox is available for Windows, for macOS, and for Linux. So if you have a Windows machine, for example, you can install VirtualBox and then do the installation. Nightwolf says, okay, I'm on a new system. I don't have a VM configured, but Docker is there. Of course, you can also spawn a Docker container if you simply want to run Fedora. I do this often using a tool called DistroBox. That makes it very easy to spawn a container with a usable Linux distribution inside. But since we are talking about beginner level Linux administration here, I'm not going to get into containers during this course. This is more of an advanced topic if you already have Linux running. Okay, so the installation is also pretty straightforward because Fedora basically suggests sane defaults. It suggests as the installation language English. I'll take that, and it'll also suggest a US keyboard down here, and you can of course change that if you have a different keyboard layout. I do think I can increase the size of this, so now you should be able to follow a little bit better what I'm doing here. So these are only 4 steps. If I want to use the defaults, here's the welcome, then next we'll have the installation method, then we'll have storage configuration if we want to do that, and then review and install. I'll click next, and now it tells me where do you want to install. Well, there aren't many options here. There is a virtual disk called VDA, 20 gigabytes. It says 21.5, but that's a rounding difference between gigabytes and GB bytes. I can change the destination if I wanted to install it somewhere else, but of course, yeah, that's the virtual disk that I created earlier with the 20 gigabytes, and I wanted to use the entire disk. I could go up here and launch the storage editor, where I could then make fine-grained changes to how the file system layout on this disk is going to look like. And yeah, let's go in there so I can make a few comments on that. Now here it says as storage we have VDA, and if I click here it tells me, yeah, the model is VirtIO disk. If we were using hardware, it would tell me the model of the SSD or NVMe drive that I'm using. It has 20 gigabytes, 20 gigabytes, which translates to 21.5 gigabytes. And the device file here is called dev.vda. It tells me we need at least 7 gigabytes of disk space, and we need 2 partitions, namely / and /boot. So I could go ahead and create a partition table. With at least these 2 partitions, and there might also be reasons to add additional partitions as well. First it asks me how should it be partitioned, and I can choose between MBR, that is compatible with all systems and devices, also older machines, and then there's GPT, which is compatible with modern systems and hard disks that are larger than 2 terabytes. It also adds more modern features, like for example, it creates a second copy of the so-called boot record, which tells the machine where the operating system is that it should boot. It copies that to the end of the disk as well. So the boot record is always at the beginning of a disk, and GPT also adds it to the end of that disk. Maybe, that's definitely an advantage if, for example, there is some disk corruption that affects the start of the disk, then there is still the copy of the boot record at the end of the disk, and that makes things a little bit more resilient. So I have no idea why there is so widespread hate around for GPT lately. Everywhere I look in social media, people are criticizing it, and I think it's a very good choice. For the partition format, MBR, by the way, means master boot record, and GPT is the general partition table. Is it GNU partition table? I'm not sure, actually. But yeah, GPT is definitely the correct choice here. So let's initialize the disk. And now it tells me, yep, I have 21.5 gigabytes of free space, which means it's time to create a partition. It tells me at the side here that I need a slash partition and a slash boot partition. So let's start with the slash boot partition. Let's call it boot. The mount point is slash boot. We'll make it x4. And the size is quite small. GUID partition table. Thanks, Compassionate Tank over on Overcast, on Owncast. Yeah, thanks for that. I was blanking. Yeah, the boot partition needs to contain the most important boot information that the machine, the hardware, or the VM needs to even load the operating system. Since these parts of the operating system are quite small, a single gigabyte should be sufficient here. And we'll talk about mount point in a second. And then we can create a second partition, which would be the slash mount point. So we'll call that root because it is the root file system. The mount point for the root file system is slash, because that is the root of the file system tree that Linux is going to use. A file system tree, what's that? Well, maybe it's a good idea to do a little drawing there. Let me just set this up. Okay. Now, the Linux file system is a single tree of files and directories. There is never more than one tree. And while that might sound strange, let's compare it to other operating systems, like, for example, DOS and...
Shut up and get in the car!
Thanks for the subscription, S6M4C. That's very kind of you. The operating systems on the Windows, on the Microsoft side of things, DOS and Windows have multiple trees because you have an C drive, which has a hierarchy of directories and files. Then you might have a D drive or a Z drive or whatever. Maybe you are still using floppy disks and have an A drive. Each of these devices has their own directory tree, and Linux is different to that, because it has a single tree, and all these storage devices that might exist become part of that single tree. So the root file system, that is symbolized by the slash, will probably contain a bunch of top-level directories, and we'll talk about these in a minute. Directories like etc or home, and somewhere down here we might even, it doesn't even have to be at the top level, we might have something like a CD-ROM drive. Or at another point we might have another big NVMe drive where we store our data. And everything is one single tree. It's a virtual file system because at a cursory glance you can't even tell, is this a directory on my primary disk? Is it an external device? Is it maybe something that comes over the network? Unix and Linux make these things very transparent, and that makes it also very convenient. You might notice the difference in terms of performance because accessing, for example, a storage device over the network is a little bit slower maybe, but you need to look very closely to see where the data comes from actually. And that makes access to these files very easy because it's all a single tree, and you can navigate between the parts of this tree without having to take account of where something is stored or not. So, of course, there is one file system with which everything starts, and that's the root file system. That needs to be there, otherwise we can't include other file systems either. The root file system is always mount point slash, and we have the choice between different file systems that have different performance characteristics, but different feature sets. The most common one is ext4. It's the 4th generation of the extended file system, which is a very traditional choice and a very safe choice as well. XFS is a file system that is especially geared towards high performance use cases. For example, for databases, it is very, very useful. And then there's BetterFS or ButterFS, which is also pretty popular nowadays because it has more features than Extended4. If you want to be on the safe side or you just don't know what to choose, then you can simply go with Extended4. That's definitely a safe and conservative choice. This second partition is all we need, all that's required. So I could use the remaining 20.5 gigabytes for this root partition. I will, however, only use, say, let's use 10 gigabytes for the system. Just for demonstration sake. And then I'll create another partition called home, and the mount point will be /home. So it will be right under the root of our single file system, and it'll use the remaining 10.4 gigabytes. Why do I create a separate partition for /home? I could also... Oh, I'm sorry. Sorry. I did forget to switch to screen sharing. Why did I only use half of the available storage space for the root file system and then the other half for home? I could simply have assigned the root file system the whole storage space and then create a subdirectory home on this root file system? Well, sometimes we want to create additional partitions because partitions come with limitations. This home partition only has 10 gigabytes, and when it's full, it's full. That's the same applies to the root file system. When the root file system is full, it's full. The problem is, when the root file system is full, we will get into huge trouble with our operating system because it can't write important files anymore, and that will plunge the whole system into deep chaos. And there is always a chance that users who have their own personal directories in /home fill up the disk. People starting to store movie files and stuff like that, and suddenly our disk of 20 gigabytes is full. And that is something that I can prevent by making /home its own partition in the literal sense. It's limited to 10 gigabytes, and when home is filled up, when the 10 gigabytes are used up, then our users will not be able to store any more files. That's probably also a problem, but it's not causing our system to get into trouble, because the root file system, which is now separate from /home, will still have space remaining, and which means we as system administrators can still use the system and still operate the system to solve the shortage of home space, but the system itself will run fine. We'll just get complaints from our users that the space is used up by someone. So I'll create that home partition as well. And with that done, I'll return to the installation. It says, storage requirements not met. Your BIOS-based system needs a special partition to boot from a GPT disk label. To continue, please create a 1 megabyte BIOS boot type partition on the VDA disk. Okay, I forgot the EFI partition, yes. So, no problem. I will simply delete the first two file systems. We haven't stored anything on that yet, so it's easy to discard them. I'll create another partition as BIOS boot partition with another gigabyte of space. And then I can go ahead and create my root file system with about 10 gigabytes. By the way, I could choose to overwrite existing data with zeros if there was something on the target hard disk that I want to be gone forever and not retrievable anymore. I can tell the installer to overwrite the existing data with zeros. And I can actually choose to encrypt a partition as well. That might be a choice that you use on a laptop, for example. So in case it gets stolen, this partition can then not be mounted without a password. So the disk itself, having access to the disk itself for a thief, for example, is not of value. But in our case, we don't need the overhead of having this encrypted. Finally, we still create the home partition and use up the remaining space here. Now, hopefully this is sufficient. Yep. Valid storage layout. So let's continue. We'll use the configured storage. I could have simply clicked use the entire disk, and then Fedora would have set up its own default partition layout, of course. You don't have to go through this whole rigmarole, but I just wanted to demonstrate it and make a few comments. And here we go, the Fedora installer takes over, and now it has actually installed the partitions as I told it to, and it's starting to install the software. Again, apologies for not switching scenes earlier. That's something that I need to get used to first. It's really quite the challenge to run this production without a team in the background. It's a one-man show here, so bear with me. And yeah, I appreciate any hints and comments to improve the whole stream here. Mystifying Disk asks, what does installation mean, by the way? What is happening there? When it says installing, now it's transferring software from the virtual CD-ROM to the actual virtual disk. I guess I'll stop saying virtual all the time. So it's copying software from the CD-ROM to the disk. As you can see, it says installing software 43%. So we are half done. The software itself is not changed during the install process. No, it's basically most of the necessary files will simply be copied as they are on the installation medium. By the way, if you are going to install Linux on actual hardware, you don't need to have a CD-ROM drive, of course. You can simply copy the ISO image to a USB flash drive. And the Fedora website, as all other distributions website will do as well, tells you how to get the ISO image onto that USB thumb drive, and then you can boot from that thumb drive and install. The process is absolutely identical to what I'm doing here. Even on a very detailed level, I don't think there is much that the installer does to the software here. It simply installs a default set of applications, of course everything that's absolutely necessary for the operating system, but it also installs a graphical environment, a desktop environment. In Fedora's case, it's GNOME, and a bunch of applications that are commonly used by new Linux users. And then later you can, of course, change the installation. You can remove packages. There are, of course, essential packages that you cannot, or at least should not, remove, but in terms of applications you can remove quite a bunch, or of course you can install additional ones as well. And every Linux distribution comes with a software package management GUI as well. So if you are installing a desktop operating system with a monitor attached, then you can simply go into that graphical installation manager and select which applications you'd like to install. Nightwolf set up a VM in Proxmox. Nice. Yeah, I thought about using Proxmox myself. I have two Proxmox instances running here, my personal Proxmox server and the Proxmox server of the server room, my DevOps community members at the Grow and Thrive level have free access to this Proxmox instance, which is running on the shelf behind me. But I thought it would be a little bit more frictionless if I simply run a VM on my system, because that then looks definitely similar to how it's going to look when you try this. Not everyone runs their own Proxmox virtual environment. So we are almost done. It's running post-installation scripts and we are done. And it says to begin using Fedora Linux, reboot your system, because if I exit here, I still get back to the live environment that has been booted from the CD-ROM. But if I shut down this system by using the power button up here, I can say power off. Yes, I want it to power off. It did actually reboot. Well, that's fine as well. If it booted from the disk now, and it did, it's not the live system anymore. It ignored the CD-ROM that is still available though. And now it's asking me to choose a language. I'll stick with English for simplicity's sake. I'll use English US, which is my actual keyboard layout anyway. And for our purposes, we don't need any location services or automatic problem reporting. I'll choose my home time zone. And it does make sense to enable third-party repositories, which widens the selection of software that I can install. Doesn't mean that we have to install a lot of stuff, but it's good to have the choice. And that is the very basic setup. And now we have to deal with the fact that Linux, just like its Unix ancestors, is a multi-user operating system. And that's why it asks us to set up at least one initial user account. So I'll do that. Well, let's go with monospace mentor, and I'll use monospace as my username. Enterprise login allows us to actually attach this to some kind of single sign-on system, like an enterprise Active Directory or something like that. Of course, we are not interested in that at this moment. Now I should set a password. And that's it. Now it's logged me in as my user monospace, and the GNOME desktop environment now invites me to take a tour around the system. I would recommend doing that if you are new to GNOME, but since I'm not new to GNOME, I'll skip that. And here we are. We have a running Linux installation with the latest Fedora workstation distribution. And by pressing the Super or Windows key, I get this dock that is a little bit reminiscent of the macOS dock. And here I can already launch a few commonly used applications: Firefox as a browser, the GNOME calendar, the GNOME file manager, the GNOME software manager, which allows me to install additional software, a text editor, and a calculator. And if I want to select different applications, I can also click here and show apps, and that shows me the whole selection that's available at the moment. And one tool we are definitely interested in, because we'll be working in it almost all the time, is the terminal. I can start it simply by clicking on it, and it gives me a terminal with a blinking prompt. And since I'll be launching this terminal quite a lot of times, I'll go into the dock by pressing the Windows or Super key and pressing the right mouse button on the terminal, and I'll pin it to the dash, which moves it over into the default selection, and I actually move it right next to my web browser here so I can easily find it. That's all we need. What we can do is, it shows me two details here. Monospace, which of course is my username, and then it says @ and then there's a name localhost-live, and that is the name of my system here, the host name of my system. And localhost live is not quite the host name that I'd like. So I'll go into the settings app, which is also probably something that you can navigate easily, because it's very similar to how it works on macOS and even on Windows. And I'll go into System, About, and here's the device name, and I can change that. And I'll change it to the short name of our course, which is Lindsys 1. Press Enter. Go out. Let's make sure it sticks. Yep, it's stored Lindsys 1. So I can leave the settings app. I can also shut down this terminal window. And when I go back into a new terminal, now it says monospace at Lindsys-1. That's neat. All right. I think it's a good idea to check if we have any questions. Wait a second. So many windows. Okay, here are two questions. What are the specs and operating system of your workstation? I'm running Bluefin, which is a variant of Fedora Linux that is geared towards developers and engineers. It has some attributes that I really like, and regulars on my channel or members of our community, the server room, know that I keep singing the praises of Bluefin. I won't do that at this point. If you want to know why I'm running Bluefin and what's so great about it, then join the server room and ask me there. My workstation has been around for a while. I bought it 3 years ago, 4 years ago, I'm not sure. It's an Intel i9 with 128 gigabytes of RAM and 2 NVMe drives. So it's quite capable to run my whole production here. It has an NVIDIA RTX 3060 in there, mainly for stream encoding and things like that. I'm not playing a lot of AAA games. My main entertainment is Minecraft, and so I don't need too much performance there. But yeah, it definitely does the trick, even if I run multiple VMs at the same time, plus my host operating system. Then there's, if I am unable to attend next week at that time, will I have the opportunity to view a recording later? Recordings will be available to members of the server room. I will store recordings there. I think Twitch will also store a recording for at least 1 or 2 weeks, so you'll be able to watch that if you do it quickly. And then there's, do I need a VM-based Fedora installation to follow the course, or is it sufficient to have Fedora on a second PC? Any Fedora installation is perfectly fine. You can simply run a VM if you don't have any additional hardware. And of course, if you have additional hardware like a second PC or an old laptop or something like that, you can install Fedora on there as well and follow the course perfectly fine. You could even install a different distribution, because most of the things that we'll be talking about aren't that different between distributions, but there might be a few nuances that are different between distributions. So in order to not confuse you, I would recommend installing Fedora Workstation. Any further questions at this time? If not, we will go ahead with the next. Oh no, we don't have. We still have to do the assessment. So let's. Oh wait, no, that was wrong. Pilot error. Let's go right into the assessment. What is the primary advantage of using GPT partitioning over MBR partitioning for modern Linux installations? Again, we'll use 30 seconds. GPT partitions are faster to access. GPT supports larger disks and more partitions. GPT partitions use less disk space, or GPT is compatible with older hardware. Yes, GPT supports larger disks and more partitions, correct. Let's wait 40 seconds for the ad break to end. If you just joined us, welcome to Monospace Mentor. Today I'm starting my live streamed course, Basic Linux System Administration. The command that you can enter in chat, !Linux course, gets you to a page with all the details. All right, let's go ahead. We can actually skip that. because the Anaconda installer is not current anymore. We did not use the Anaconda installer earlier because Fedora 42 is the first version of Fedora Workstation that came with the new and improved web-based installer. So let's go right ahead. What is the recommended minimum amount of RAM for a comfortable Fedora installation experience? Not sure if I mentioned that actually, but if not, take a guess. We have 1 GB, 2 GB, 4 GB, and 8 GB. 4 GB is the recommended size that you should have at least, of course. You can always go higher. As I said, I'm using 128 GB here. Actually, there are Linux servers in the wild that have RAM in the terabyte region. But 4 GB is a good place to start. I did not talk about the root account, and I should do that. That's definitely an omission. When we created our user account, there was already a account in the background that always gets created, and that is also called root. Like the root file system, but in this case, root simply means that is the super user, that is the administrator user, that is basically God on the system. The root user can do everything, including completely destroying the system. That is actually why the installer doesn't even mention root. It also doesn't let you set a password for the root user. The root user on a standard Fedora installation is basically locked down and is usually not used directly. And that's why the installer went right ahead and asked you to create your own user. Your first system user does have administrative capabilities, but only if you explicitly tell it to. The reason, of course, is security, because if you use the root user account to log in and do all kinds of stuff, the risk of doing something that will accidentally screw up your system is, of course, there. And that's why root isn't talked about during the initial installation. Of course, when you need to start system administration tasks, you need to be not only aware of the root account, you actually need to use its capabilities, and we'll get to how you can do that. And that basically is the explanation why we have this question here. Why is it considered a security best practice to create a separate user account instead of using root for daily tasks? Is it because root accounts are slower to authenticate? Is it because user accounts have access to more software? Is it because root access increases security risks if compromised? I would say not only if compromised, but also if used accidentally. And user accounts automatically create backups. Everyone is of the opinion that it increases security risks, and that is of course true. I did not actually mention that. So let's take another guess. Which file system is Fedora's default choice for most installations? Is it XFS? Is it Btrfs? Is it extended 4? Or is it ZFS? I did use extended 4 when I installed my system earlier. And that's probably why almost everyone also selected extended 4 here. But the actual answer is Btrf. No, it's extended 4. I think it's Btrfs. In Fedora 42, it installs on Btrfs by default. This is not updated. That might have been the case in earlier. That has been the case in earlier Fedora versions. Extended 4 is still in use. But the latest versions of Fedora, at least Fedora 42, uses Btrfs. So actually this is not correct. Apologies. LVM is something that I skipped. We'll get to that later. And we did not cover these things as well, so I will actually cancel that poll and go right ahead into the next chapters, because we need to get ready. We have been running for almost 2 hours now. Wildchen says Btrfs is the default in Fedora since 33. That's quite a while actually. Failsleep asks, with what's happening with Btrfs and the kernel, do you think Fedora will revert to ext4? I don't think so. Oh, they even asked it on the board as well. I think Btrfs will remain in the kernel for the time being. It's not a debacle like with bcachefs. Okay, I need to do a little bit more setup now. Change Windows for the next. Chapter. Where we'll talk about the architecture of Linux. All right. Let's talk about the difference between kernel and user space. That's something that you definitely need to understand if you want to do Linux system administration. And again, keep the questions coming, post them to the board, and if you don't know how to get to the board, enter !interact into chat and press enter. The Linux operating system is fundamentally divided into two distinct realms, kernel space and user space. Think of this division like a well-organized company where the executive team, stand for the kernel, handles critical decisions and resource allocation, while the various departments, which are the user space applications, focus on their specific tasks without worrying about the underlying infrastructure. The kernel is the core of Linux. It's the only part of the system that has direct access to your computer's hardware, the CPU, memory, disk drives, network interfaces, and all other physical components. The kernel acts as a translator and traffic controller, managing requests from applications and ensuring that hardware resources are shared fairly and safely among all running programs. When you run a program like a web browser or text editor, that program operates in user space. User space applications cannot directly access hardware. They must ask the kernel to perform hardware operations on their behalf. This separation is crucial for system stability and security. If every application could directly control hardware, one misbehaving program could crash your entire system or access sensitive data from other applications. The communication between user space and kernel happens through so-called system calls. These are like formal requests that applications make to the kernel. For example, when you save a file in a text editor, the application makes system calls to write data to the disk. It asks the kernel to write data to the disk. The kernel handles the complex task of translating this request into the specific commands needed by your particular disk drive. This architecture provides several critical benefits. First, it ensures stability. If an application crashes, it typically won't bring down the entire system because the kernel remains protected. Second, it enables security. The kernel can enforce access controls and prevent applications from interfering with each other. And third, it allows portability. The same applications can run on different hardware because the kernel handles the hardware-specific details. Applications don't have to worry about this. Understanding this fundamental division will help you troubleshoot system issues more effectively. When something goes wrong, you'll know whether you're dealing with a kernel-level problem, like a driver issue, or a user space problem, like an application configuration error. Now that we understand the basic architecture, let's explore how you interact with this system through the shell. The shell is your primary interface for interacting with the Linux system, especially when performing system administration tasks. Think of the shell as your personal assistant who understands your commands and translates them into the appropriate system calls that the kernel can execute. When you open a terminal, like I did earlier, you're actually starting a shell. The shell is just another user space application, but it's a special one because it's designed to interpret your commands and launch other programs. The most common shell in Linux is called Bash, the Born Again shell, named after Stephen Bourne, I think. B-O-U-R-N-E. And you might also encounter Z shell, Fish, and other variants. There are also historical shells like the actual Bourne shell or the Corn shell, for example. There's also the C shell and the TC shell. But Bash, Z shell, and Fish are probably the most common ones nowadays. The shell provides several powerful features that make system administration efficient. You have features like command history that allows you to recall and reuse previous commands, which is invaluable when you're repeating similar tasks. Actually, let me demonstrate that right away. So, screen lock.
Hide the planet! Hide the planet!
Thanks for the subscription. That's very kind of you, Nivo90. Let's try again. Yeah, okay. So, in this terminal, we are in the actual shell. And I can enter commands here, like, for example, echo hello, linsys1. And the echo command will simply take what comes behind it and outputs it to the screen. So this text will actually just appear. And if I want to repeat this command, I can actually simply press arrow up. And here we are again. And I can say, hello course participants. I can edit this line as well by using cursor left and right and backspace and things like that. And then this command history becomes very helpful. Then there is tab completion that helps you type commands and file paths quickly and accurately. Let me demonstrate that as well. So if we go here, we can, for example, change into the root directory with the cd command, and then we'll use the slash, the same slash that we used when we created the root partition. And if I enter ls here, it lists me all the files in this root level. And you can see there is AFS and boot and etc and image and media. The color scheme is maybe not really helpful. It's lacking contrast a little bit. So let me see if I can actually change the color scheme in the preferences here. Dracula should definitely, that's Dracula, right? Yeah, that's my favorite color scheme, and that should make things a little bit better, easier to read. Now, if I want, for example, to cd into lost and found, I can, of course, type that in, but I can also just type lost and press tab, and then the shell will automatically finish it for me. In this case, it is unique and unambiguous, so it finished it completely for me. If I enter L and press tab, nothing happens because L is ambiguous. It could be lib64, it could be lib. Yeah, those two start with L. If I press tab a second time, it actually tells me, oh yeah, there's lib, lib64 and lost and found. Which one of these shall it be? And so I might actually have to type lib6 if I want to go into lib64, and pressing tab now doesn't make much sense. It'll just, at the final 4, I could have typed that as well instead of typing tab. But yeah. Then I can go back to the root of our file system by doing cd/. That's tab completion. Then there are wildcards and globbing, which let you work with multiple files at once using patterns, and we'll get to that in detail later. And in your own home directory, to which you get if you simply enter cd, that gets you into your home directory, which is also symbolized by the tilde sign here in this shell prompt. As you probably noticed, my current directory got displayed here in my shell prompt, which is the part before the blinking cursor. When I changed to the root directory, it showed /, then I changed into lib64, so I changed to lib64. And now that I entered cd to get into my home directory, it shows me the tilde, which symbolizes my home directory. If I want to know what this home directory is actually called, I can use the pwd command, which prints my current working directory. And we can see it's in /home/monospace. So this home directory is actually in that separate partition that I created specifically for /home and everything in it. Which means In this home directory, I now have about 10 gigabytes of storage space and not the full 20 gigabytes that I used as the disk size for my VM here. If I do an ls in here, I can see that the installer already created a bunch of directories for me. And those are typical directories that desktop users use, like documents or music or videos. And there are actually also hidden files that you can reveal by adding the option -A to ls. And now you can see that there are additional files other than desktop and documents and those up here. Files that are called .bash profile, .bashrc, .config, .local, even .mozilla. And all these files have in common is that they start with a dot. And that is actually what makes them hidden. The ls command without the -A option ignores files that start with a dot, because those are files that you don't usually access every day, but they are important because, for example, they are used to customize your shell's behavior. The .bashrc, for example, sets up specific configuration settings for our shell, which is bash by default. And in this .bashrc file, you can make changes to how the shell behaves. We've already talked about the prompt, which is the part left of the cursor that can display different things. In our case, it displays my username, then the host name after the @ and then my current working directory after the colon. And that is, for example, something that you can change by making changes to the .bashrc file. We might be getting to that later when we talk about the shell in detail. Otherwise, it'll be an interesting research homework for you. The shell is where you'll spend most of your time as a Linux administrator, so becoming comfortable with it is will significantly improve your productivity. And so let's take a look at the file system. I think it doesn't switch. Slides. Let's talk about the file system hierarchy standard. We already talked about the Linux file system being structured in a certain way, and we've already seen a few directories actually that are based at the top level of the root file system. And these directories mostly follow a standard that is called the File System Hierarchy Standard, FHS. The Linux file system follows a standardized organization called FHS. This standard ensures that regardless which Linux distribution you're using, important files and directories are located in predictable places. It's basically like an universal addressing system for Linux. You learn that, and then you can navigate any Linux system with confidence. The file system starts at the root directory, which is symbolized by the /, which is the top-level directory that contains everything else. Unlike Windows, as I said, with its drive letters, CD, etc., Linux presents a single unified hierarchy into which all storage devices are integrated transparently. The Linux file system is always a single tree structure. So let's explore the most important directories you'll encounter as a system administrator. There is /bin, which contains essential system binaries, which are executable programs that are needed for basic system operation and repair. The ls command, for example, or other very essential shell commands are located in /bin. These are programs that might be needed even when other parts of the system aren't fully functional. /etc is where system configuration files reside. This is perhaps the most important directory for system administrators. Here you'll find configuration files for services like web servers, network settings, user account information, and system startup scripts. The name etc historical stood for etc, but you can think of it as everything to configure. /home, as we've discussed already, contains user home directories. Each user typically has a subdirectory here, like my/home/monospace, where their personal files, configuration, and data are stored. Your personal shell configuration files like .bashrc live in your home directory. Then there is /var. It holds variable data, files that change frequently during system operation. This includes, for example, log files in /var/log, temporary files in /var/tmp, and data for running services like databases or web servers. So there might be, for example, a directory var/lib/mysql that stores the data of the MySQL database system. When you're troubleshooting system issues, you'll often find crucial information in /var/log, for example. Also in different places, but we'll get to that. /usr contains user-installed software and files. Actually, historically, even home directories were stored in /usr because it stands for user. They just kept these names very, very short. But that changed over time, and now /usr is mostly system binaries, system applications, and nothing that is related to the system users. There is also another bin directory under /user, which contains additional binary programs. Then there are libraries under usr/lib and documentation in /usr/share. Walden asks, I thought /usr stands for Unix system resources. Yeah, that's another instance where the meaning changed over time. You might have noticed that blinking lights thing behind me. That is a model of a PDP-11 mini computer, and I can actually run historical Unix systems on there. For example, Unix version 7, which was released in, I think, 1975. If you log into that Unix version 7, you'll see that in /usr is actually even user home directories. When when Unix got more widespread, people realized /usr should probably be relegated to system level stuff that doesn't change often, because then we can actually make it read-only if we want, which meant, of course, user home directories had to go somewhere else, because yeah, making user directories read-only would probably not have worked very well. And that's why users were relocated to /home, and /usr is now system level stuff. Everything goes into /nix/store. Yeah, that's definitely the case in Nix-based systems or systems that use the Nix package manager. This directory will definitely grow quite well over time. But that's nothing we'll discuss here. Okay, then another more modern addition is /opt. It's for optional software packages, typically third-party applications that don't integrate closely with the rest of the system. /opt basically was, I think, a response to stuff being scattered a little bit in the traditional file system, because, for example, you'll have system applications under /usr, but their configuration will be under /etc. And maybe they'll store their variable data under /var. And I think /opt is inspired by other operating systems where everything of that relates to a specific application is under the same main directory, where you have /opt/ some application, and then under there is both the configuration and the binaries and the variable data and everything else that is related to that application. So that's why you'll see /opt in modern Linux systems as well. /tmp provides temporary file storage that is usually cleared on system reboot. /tmp is writable by all users of a system which has some security implications, but it's an easy way to create temporary files for system applications and system users alike. The tmp directory might also be a good candidate to put into a separate partition, especially on Linux servers, where you don't want temporary data to fill up your disk until the whole system gets in trouble. For example, on our web servers and similar servers, we put TMP into a separate partition and limit it to, say, 10 gigabytes or something like that. That should be sufficient for temporary data. But even if that fills up, it doesn't affect the rest of the system, and that's often something that you want to have. Then we have /dev. And that is an area where you can interact with the Linux kernel. /dev contains device files that represent hardware components. So every hardware that's built into your system probably is represented by directories and files under /dev. These aren't regular files, but special files that provide an interface to hardware devices. For example, my partitions are visible under /dev/VDA 1, 2, and 3. That is something that I can show you actually. So let's go over there. I probably should disable the screen lock here. So if we ls/dev, there's a lot of stuff in here. And here we actually have my virtual disk represented by the file VDA. It might actually be a directory, I'm not sure. No, since it's yellow, it's a file. And also my partitions VDA 1, 2, 3, and 4. So my actual physical yet virtual partitions are represented as files here. And this is a good point to mention a philosophy that Linux inherited from Unix, and that is everything is a file. Everything that is somehow relevant to the system and somehow relevant for users is represented by files. Even if they are just virtual files, for example, VDA, the file that represents my hard disk or my storage disk, is of course not really a file, but I can interact with this file, and by interacting with it, I communicate with the kernel, and I can actually send commands through this file to the kernel. I could, if I wanted to, and would make it extra challenging for myself, use this file VDA to maybe create another partition or something like that. No one does that except the programs that are there to partition a disk. So if I would enter a partition management software, then that software would use these files to tell the kernel to delete a partition or to add a partition, depending on what I wanted to do. So there aren't any specific interfaces other than the aforementioned syscalls. Everything that is more complex is done via files in the file system, and many things that are related to devices, to physical hardware, is done through the /dev directory and all that's in it. The relast, please can you tell us a little bit about the difference between Unix and Linux file systems? We might get into that on the forum in the server room, but that's out of scope for this course because I'm running out of time as it is. I'm sorry. So, back to the file system hierarchy standard. Understanding this FHS helps you to predict where to find files and where to place new ones. When you are looking for a configuration file, you know to check /etc. When you are troubleshooting a service problem, you know to look in /var/log. This knowledge makes you much more efficient at system administration tasks. The FHS provides the organizational structure that makes Linux systems manageable and predictable because it's a standard that is used on basically all Linux distributions. Now, let's look at the processes that brings this file system to life. Every running program on a Linux system exists as a process. Understanding processes and how they're managed is fundamental to system administration because processes are what actually do the work on your system. Think of processes as the workers in a factory. Each one has a specific job, uses certain resources, and needs to be managed and coordinated with others. And we'll talk about processes in details in a later chapter as well. When your Linux system boots up, the first process created is the so-called init process. There has to be one initial process, and it's called actually init. It always has the process ID or process number 1. This process is the ancestor of all other processes on the system. The init system is responsible for starting essential services, for managing the boot process, and maintaining the system during operation. Modern Linux distributions typically use systemd as their init system, though you might encounter older systems using system5 init or upstart. So there are processes that you'll see at the root of, again, another tree, namely the process tree. Nowadays it's systemd usually. There are a few distributions that don't use systemd, and they might still be using the traditional system5 init, which Linux inherited from Unix, or upstart, which is another process manager. Systemd is actually more than just an init system. It's a full system and service manager that handles everything from boot time initialization to ongoing service management. As I said, we'll cover that in detail later. Processes exist in a hierarchical relationship, forming a process tree. Lots of trees in Linux. Each process, except init, has a parent process that started it. So it all starts with init. It has child processes, which might again have child processes, and that's how this tree gets wider and wider. When you run a command from your shell, the shell becomes the parent of that new process. So when I executed the ls command earlier, my shell started a child process of itself that ran this ls command. This relationship is important for understanding how signals are handled and how processes can be managed. I can actually show you how this looks like. Because there is a nifty command called ps3 that shows us the process tree. And there are a lot of running processes, even though I did not do much on this system, but that all happens automatically during the boot process. And if we scroll just to the top here, you can see the ancestor of all of them is systemd. And then there is the accounts daemon, whatever that daemon is. Please, anyone don't call an exorcist. And it spawned 3 children, which are also called accounts daemon. And there's lots of stuff else that provides me with this graphical interface and runs stuff in the background, makes sure the screen gets locked while I'm talking, stuff like that. Each process has several important attributes. There is the process ID, which is a unique number that identifies the process. The parent process ID, short PPID, identifies the process that started it. Then there is a user ID that determines what permissions the process has, because it's related to the user that started the process. The process state indicates whether it's running. It may be sleeping, which is it does nothing at the moment, it's just hanging out there. It might be waiting for something to happen, for example, for data to come in, or it might be stopped, which is that it's basically frozen. That's something that you as a system administrator can do, for example. Process management is a core system administration skill. You'll use commands like ps3 or ps to view running processes, and top or htop to monitor system activity in real time, and even a command called kill to terminate processes when necessary. So let's take another look. If I go in my terminal and I use the ps command, I get a list of processes that are running as my user. It's not much. It's just my shell that's running at the moment and the ps command that generated this output and then terminated itself. If I run another ps command, you will notice that the shell still has the same PID because it's still the same shell process that's running. However, the ps command now has a different process ID because this is a different process than the one that ran earlier. This one ended after making this output, and this one, 4083, is now terminated as well. If I want to see all those processes that seem to be running on my system, then I can use additional options like, for example, AUX, which shows me a lot of additional information. It shows me all the system processes. It also shows me the user that is behind these processes. So there is a root user underway and there is monospace. These are the 2 users that we'll encounter here, because it's either me who's doing stuff or it's the system doing stuff as the root user. And then there is a lot of detailed information about all these processes as well. And I would probably have to make this window a little bit bigger and run the same command again, so I get a little bit more information. And then there's a command like top that shows me information about the running processes, and it updates this information every second. So I get a running view of the system, what's going on here, and which processes are using up system resources at any time. Of course, my shell, which is called GNOME shell here, my terminal GNOME shell, is at the top here because yeah, it's the most active process on the system at the moment. Hungry Bear says, wow, your stream is so clear and your code is not even full screen, but I can see clearly. Glad to hear it, because earlier when we started the Linux installation process, the text was so tiny that nobody could actually see what I was doing. Thankfully, that was only short-lived. But yeah, if there's anything with the stream, good or bad, please let me know so I get a little bit more peace of mind. Understanding how to read process information helps you identify resource usage patterns and troubleshoot system performance issues. I've been talking about services, which are basically processes. Those services are usually long-running processes that provide functionality to the system or to other applications or to other users. Examples include web servers, database servers, and network services. Those usually run for a long time and provide some kind of benefit to someone, and that's why they are usually called services. And the init system manages these services, which is why sometimes they are also called service managers. They start services at boot time, restart them if they crash, and can be controlled, of course, by system administrators. Systemd uses unit files to define services and their dependencies, and we'll get to those later. These files specify how services should be started, what other services they depend on, and how they should behave in different situations. This dependency management ensures that services start in the correct order. If they depend on each other, then the order of startup does matter. And that related services are managed together. Understanding processes and the init system gives you the foundation for managing running services and troubleshooting system issues. Let's look at how Linux interacts with hardware now. One of Linux's greatest strengths is its ability to run on an enormous variety of hardware, from tiny embedded devices to massive supercomputers. This flexibility is achieved through hardware abstraction. The kernel provides a consistent interface to applications, regardless of the specific hardware underneath. For example, I really don't want to deal with the actual model of hard disk that's built into my PC. I just want to create partitions on it and store my data on it. And I leave everything else to Linux, and Linux has drivers built in that can handle most common NVMe drives and stuff like that, so it takes care of everything for me. The key to this abstraction is the device driver system. That's similar to other operating systems as well, of course. Device drivers are kernel modules that contain the specific code needed to communicate with particular hardware components. When you install a new piece of hardware, you typically need to ensure that the appropriate driver is loaded. Modern Linux systems include drivers for most common hardware, and additional drivers can be loaded as needed. We've already talked about the dev directory. It contains and represents hardware devices as special files. This everything is a file philosophy means that you can interact with hardware using the same commands and programming interfaces you use for regular files. Linux inherited this everything is a file philosophy from the Unix operating system. It's a unified approach and means that the operating system treats virtually all system resources, including hardware devices, processes, they are also represented as files, network connections, and inter-process communication mechanisms as files that can be accessed through the standard file system interface. So everything, the tools that you use to deal with files allow you to also deal with hardware. There are different kinds of devices. There are two main categories. One is the block devices. They represent storage devices like hard drives, SSDs, and NVMe drives, etc. These devices transfer data in fixed size blocks and can be accessed randomly. You can read from any location without having to read through all the preceding data. These are not tape drives anymore, for example. Block devices are typically mounted as file systems. so that applications can store and retrieve files. Mounted means they get integrated into the file system tree at a specific point. And it's up to you as the system administrator to decide where these devices actually pop up. The other category are character devices. They represent devices that transfer data as streams of characters. A typical example is keyboards, mice, and serial ports. These devices are typically accessed sequentially, character by character. That's why they are called character devices. Network interfaces are handled somewhat differently, appearing as named interfaces, again as files under /dev dev, like for example ETH0 for Ethernet or WLAN0 for wireless. These interfaces are configured using networking tools. They usually don't appear as files in /dev. I'll skip over the UDEF system. That is a little bit too deep at the moment, and we'll need to get finished for today. Even though there are a few more chapters, so we'll have to continue next week. I'll probably have to speed up things a little bit and cut down on information. Let me see. Oh, at least we are finished with this chapter. So let's go into questions and answers. You can still send questions to our Q&A board. The command !interact gives you all the details that you need. Just enter !interact in chat and press enter, and you'll get guided to a web page on my website that tells you, that shows you actually the Q&A board. So you can submit questions if you have any. While I see if I can already trigger an ad break over on Twitch. Yep, I can. So while we are collecting questions for this final chapters, I'll continue with the rest of this module next week then. I'll trigger an ad break. Okay, so we'll do this final Q&A round and the assessment for this chapter, the final quiz, and then we'll wrap up for today. We are almost finished with the ad break. All right, we should be back. These ad break only affect viewers on Twitch. And here's one question. When I install a deb file, which I downloaded and I execute it just from where I put it, where does it install? That's a good question. So Linux packages, regardless if they are in the deb format for Debian and Ubuntu, or if they are in the RPM format for Red Hat Enterprise Linux, for Fedora or OpenSUSE, they contain usually a whole bunch of files. Configuration files, program files, other stuff. And it's actually the package itself that contains the information where the package manager is supposed to put them. So the package itself tells the package manager, this is a configuration file, put it in /etc. This is a program binary, put it in /usr/bin. This is a library file, put it in /usr/lib. So the package manager actually reads the package and gets the whole structure, what is to be installed where, from the package itself. I hope this answers your question. If not, you can feel free to send follow-up questions. But if there aren't any more questions, then we'll go right into the final quiz of the day. Which command is used to check the status of system services in modern Linux distribution? We did not discuss this. Let me check if I went a little bit more quickly over this than this quiz was designed for. Let me check what this quiz looks like. Actually, so many windows here on my desktops. That's the problem with a one-man show. Let's see the actual quiz. Here we are. I didn't skip all the questions from the previous install section. So let me see if I can skip forward to Linux architecture. Yes, I can. All right. So, which component of Linux has direct access to computer hardware? That's easy. Is it the shell? Is it user space applications? Is it the kernel? Or is it the init system? 30 seconds. Correct, it's the kernel. Only the kernel itself has direct access to computer hardware. It can, of course, offer specific features to user space applications in a very controlled manner, though. What is the primary purpose of the /etc directory, /etc directory? Store user home directories? Maybe historically? Store system configuration files, store temporary files, or store device files? Yeah, that's another 30 seconds and should be easily answered in that. That was another easy one. Everyone answered correctly. It's for system configuration files. Which process always has PID 1 in a Linux system? The shell, the init process, the kernel, it's very central, or the login process? Because it's the first thing that you see when you boot your system. It asks you to log in. I am already a little bit tired, but you don't seem to be. The init process is, of course, correct. Well done. That question should be easier as well. What type of files are found in the /dev directory? Is it configurations, logs, devices, or temporary files? Looks like we are getting a very easy quiz to round things out. Of course, as the name implies, it's device files. Shall we even do this question? Which directory contains variable data that changes during system operation? /usr, /etc, /var, or /bin? I guess it's good to hammer this home, so there's no confusion at all. I'll have to admit, those are quite the leading questions that I wrote there. Of course it's var. This is actually an important question, but we covered that as well. What is the main advantage of the separation between kernel space and user space? Is it faster program execution? Is it better system stability and security? Is it reduced memory usage? Or is it easier programming? Because kernel programming is hard. I have the highest respect for people who are doing kernel level programming. Because if you're doing something wrong, there it'll screw up a lot of things. But the answer is, of course, better system stability and security. If user processes are separated from the thing that can do everything, it's probably a good idea. What's the most common shell in Linux? Is it the C shell, named after the C programming language, used in programming and developing Unix and Linux? Is it Bash? Is it the Z shell? Is it Fish? Does anyone use Fish? Nightwolf says, I get a bit of latency on the stream. It's about 30 seconds and definitely later than Twitch. All right. I'll check my own cast instance. Maybe it's running out of resources or something. Yes, of course, it's Bash. Okay, next question. Can we do quicker? Yeah, we can do 10 seconds. Now I added 10 seconds. Let's cancel that timer. Let's do 10 seconds. What's the root directory? Quickly. Nitro says most common shell. For me it's Z shell. For me too. Mystifying Disc says, before I fall asleep, yeah, it's late, especially if you're in Central European time. I really learned a lot tonight. I struggled since about 3 years to become a proficient Linux user, but I understood some very basic things tonight for the first time. Thank you. Very happy to hear that. I'll do a quick survey in a few minutes and would really appreciate it if you could get me some feedback. I also learned a lot about pacing and stuff in this first session today, so next time we'll be a little bit quicker to get through our whole curriculum. but it's nice to get this positive feedback. Thank you very much. Wildjan asks, isn't SH the most common shell? It's installed everywhere and has been there for decades because it's one of the foundational shells, the original born shell that has been around since the olden Unix days, but it's not commonly used. So that was what I intended by this question, which is the most commonly used and installed and configured shell. Nitro says, yes, my laptop has Fish as default on Cashy OS. Okay. I know about Fish, but I've never used it myself. Never saw the need to go away from C shell. With or without Oh My C shell, I started out using Oh My C shell, as most of us do, but by now I have a very pared down Z shell configuration that you can look at if you look at my .files. The !.files command actually gets you to my .files repository on GitLab, if you are curious how my Z shell configuration looks like. The root directory is, of course, the / directory. The tilde directory is the symbol for the home directory of you, the user that's currently logged in. All right. That gets us to the next chapter, but we'll start that next time. So let me go and enable the final survey. That is now enabled. You should be able to see that as a clipboard icon in your board. Let me see, do I have a tab open for that? I should. Maybe I closed it. Now I do. I'll need to stop the poll. Where are we? Let's dismiss that. Now you have the additional clipboard icon with a red dot, which is the end of session survey. If you could take a minute or two to enter the course feedback, I would really appreciate it, because it helps me dial in how I do this course. This was the first time that I did this. I hope you had fun, and I hope it was informational and educational for you. I did have fun, even though it's really a challenge to talk for 3 hours on end. But it's a lot of fun to share my knowledge, and I hope you can benefit from that. If you don't follow my channel or have not subscribed to the channel yet, please do so, so you get notifications when I go online next time. The next time that I'm going to do this course is, of course, next Thursday at the same time as today. If you have not yet signed up to this course, I would appreciate it if you use the URL behind the command !Linux course to sign up with your email. That simply registers you for my newsletter, and that allows me to inform you if we have schedule changes. For example, if there's a Thursday I can't do the course for health reasons or whatever. And it would also help me to gauge how many people are actually taking part actively in the course. What else is there? I think that's basically it. Again, if you could take the time to take the course feedback survey, that would greatly help me. And other than that, I guess that's it for today. Where's the link? You mean to the survey? !Interact gets you to the page, and at the bottom of this page is the participation board. Click the clipboard icon there, and there is the course feedback survey that I'll run at the end of each of my sessions in the coming weeks. I might have to think of a less complicated way to get there. But yeah, I guess it needs to start somewhere. So !interact is what gets you there. Any final comments? How was it? Did you have fun? Was it informational? I guess I am well aware these were very basic, very foundational things that many of you might already know. Maybe there was a tidbit in there that you didn't. And of course, in the coming modules, there are still the rest of this module and 9 additional modules going to come. And yeah, it'll be more meaty in future sessions, definitely. So yeah, I hope you had fun. I would like to see you again next Thursday, and maybe in between in my other live streamings. Oh yeah, I'm getting tired. In my future live streams. For example, tomorrow is Friday, and at Friday at 2 p.m. Dublin time, I always do my office hour, where all I do is collect questions from viewers about DevOps, Linux system administration, software engineering, all that kind of stuff. A full hour dedicated to your questions and to my answering. If you like, pop by and ask questions yourself. Yeah, until next time, take care.